We are now going to provide definitions for to inequalities. And an inequality is anytime we have an expression with an inequality in an expression, where this inequality is greater than, less than, greater than or equal to, or less than or equal to. And if we see any of these, then we're dealing with an inequality. The domain of an inequality is the set of all real numbers for which both sides are defined. And the solution to an inequality is the set of all real numbers for which the inequality is true. Meaning when I plug it into the original, I get my exact answer back, or it comes out as a true statement, such as 4 is greater than 2. Then whatever value gave me 4 is greater than 2 is a part of the solution. Now to solve means to isolate the variables to find when the inequality is true. And so we want to get all of our variables by themselves so that we can deal with them and figure out when they're true and when they're not true. Now, just like with our equations, we had conditional, contradiction, and identity, we have the same thing here. Conditional is when some non-complete set is true. In other words, anything but minus infinity to infinity or the empty set. A contradiction is no values are true. Nothing you plug in will ever make it true, such as a very simple inequality, -2 is greater than 4. This can never be true, so this is a contradiction. And an identity is when all real numbers are true, meaning our answer goes from minus infinity to infinity. And notice that I'm using interval notation. Interval notation is by far and large the most common way to answer an inequality. Now, we've got a couple of other rules that we want to make sure we know, and that's if x is a real number, then x squared will always be greater than or equal to 0. This is called the non-negative identity. And for equivalent inequalities, it's just like equivalent equations. This means that the solution set is exactly the same for the two inequalities. That means they agree exactly. If they agree exactly, then they are equivalent inequalities. If they don't, then they're not. And so those are the definitions that we're going to be using in this section.